Okay. Hello, everyone. I'm Chang-Wu Chen. I'm Token. Currently, I'm a chief scientist leading a research lab in Taiwan, and we are working on the wallet design and also the DEX design because we have a built-in DEX called Tokenon. So today, I'm gonna talk about mass adoption of crypto wallet because how do we build a thing that we can onboard in billion user in the next couple of years? So I think this is a kind of challenging and also provides some opportunity. So let's begin with the native transaction in Ethereum. So today, if you want to send if the user want to send a transaction, it's a EOA account, and then we will assign a transaction format, standard transaction format, and then broadcast the transaction to the Ethereum node, and then get to the validator node to being validated, and to check whether the signature is valid or the fee is sufficient, and then we can execute the code. So this is a standard, transaction lifecycle in current Ethereum design. If we look at the account abstraction transaction, so this is a very different design from the transaction lifecycle that I just showed in previous slide. So the first part is in account abstraction transaction, we introduce a new component called bundler. And that bundler will help to relay the signing message to the Ethereum nodes. So here you can see this is not the standard transaction format. It's a signing message. It's just like, hey, user just want to make some kind of action. Here I will call it as an intention. And then the bundler here will help to check this signing message, the signature is valid, and then it can execute and then try to simulate if it can pay the sufficient fee. Okay. So there are several questions. So how did this work, and how did this make the benefit for our users? So the first part is my favorite part is signing message. Because this is not the standard transaction format, so it could be any kind of format that's in message, but the user can sign in this kind of intention and encrypt into the transaction format. And another part is we can see because on account abstraction wallet, this is not an EOA account, it's a smart contract account. So that means so first, we can have two different accounts. One is account and the other is signer. And the account doesn't equal to the signer. So first, we can pre-compute the address. So this is a very important property on account abstraction. Because in the EOA way, when a user wants to access the wallet, they need to deposit some Ether into the wallet. But if we can pre-compute the address, we can do a lot of things. So think like if we we can have several onboarding schemes that if you want to incentive user to use or create the wallet on your service side, then you can pay him maybe $10 or $50 as the incentive to encourage him to build a wallet with your platform. But with the EOA, you cannot do that because you need to create the private key before you can get the address. And the second reason is we have account recovery because account doesn't equal to the signer. So we can change the signer once they got lose their private key. And the third thing is we can also make the gas abstraction. So this is always the pain point when we onboarding the user because just like I mentioned, user need to get some Ether before they can send a transaction. But if they can pay the transaction fee in ERC20 token or in the fiat, then it's easier to onboard the more users. Next, I will dive into several properties. So first, key management. So in the account abstraction, I think the very different way is because if we can abstract the signature algorithm, so that means any kind of private key we can use to sign a transaction. So this give us another reason. We can use something like passkey or FIDO2 or WebAuthn. We can use any kind of private key mechanism to sign a transaction. So this is really helpful for the user to protect their private key because for the passkey, the private key could be generated into the secure element in the iPhone or the Android. So user don't need to remember the C phrase. And also, this also improves the user experience because the private key is in the secure enclave. So you can use the Face ID to unlock your private key to sign the transaction. Account. So since the account abstraction is a smart contract wallet, so that means the account actually is building in a smart contract. So that means we can open source the smart contract. So this brings something like we can have a lot of diverse front-end application because everyone can base on the smart contract to build their wallet. It's not necessarily should be from the imToken or other company. Anyone can build their wallet based on the smart contract. And third, because of the account is fixed, so we can extend to DID application. So I think DID might be promising once we can get the account abstraction work. Address. So for address, I think this is a difficult part because for EVM chain, it's easier to derive the address because we can use create 2 or create 3. We can use it to fix the address. But on the non-EVM chain, something like maybe StarNet or zkSync or other like Bitcoin or something, you can't have the fixed address to help the user to send a transaction because for current pattern, user always to send the transaction to the fixed address. So we need to have ENS. Yeah, so this is the original address generation way. We have a private key and we can derive public key and then we can use public key encoding to derive the address in the several blockchains. Verification. So for the verification, this is an important part because we can abstract the account. So that means we can use lots of verification scheme to verify the transaction. So here I show we can use signature or genealogy proof or session key. And for signature, you can do something like aggregate the signature using the BOS or Shinoa signature. Also, you can use the original way in multi-sig scheme. Or you can use the MPC threshold just like the MetaMask demo. Signing message. Just like I mentioned before, because for now, account abstraction account, the user don't need really sign a standard transaction format. It's just the message. So the message could be in any kind of form in the platform. So like email, message, or social media. So in the email, in the future, you might be send a transaction through the email because email has the DKIM protocol. It has a built-in private key. So you can sign the message with the email system. And the bundler, which can decode the transaction from the email text and then send it to the transaction. Yeah, so this is more like this is intent. So you can sign or send the transaction anywhere. Paying gas. So paying gas, yeah, this is the pain point for the user to onboard because they need to have some get some ether before they can send a transaction. But with the account abstraction wallet, then they can, because there is a new component called paymaster. So when the user wants to send a transaction, he can specify what kind of scheme he wants to use to pay for the transaction. So here he can pay for fiat, USDC, USDT, or maybe NEV, because for now, FreshBot just introduced a kind of scheme called MapShare. Once the user trade, they can rebate some or refund the token to the user. So this could be improve the onboarding user experience. And the last is account recovery. So for account recovery, I think there are several schemes could be introduced in the future. There are two kinds, maybe on-chain or off-chain. So for the on-chain, originally we used the multi-sig, but now we can have identify authentication, maybe use the government ID or the Web2 scheme. So there is a project called ZK Email. So we can use email to verify the ID, and also use the institution KYC rule. So for the off-chain, we can have several ways, like Shamir secret sharing, or we can just recover from the cloud. So I think in the future, we will have a lot of customized recovery service. Yeah, so when, let's summarize all of this. Since the smart contract can plug in lots of ways, so I think in the future, modular smart contract will be the future. And look at this user profile. Try to imagine when you start to learn crypto or have a first crypto wallet. You might be a student. So at this moment, you know nothing. You know nothing about crypto wallet. But once you start to learn crypto knowledge, you become a developer. So you know how to secure your wallet. And then maybe the student is lucky and got the fortune, and so he becomes an investor. So at this moment, you don't really care about how to trade. You only need, you don't really want to know how to really secure my asset. And the last, with the time going, because the developer, just like under the second, under this kind of situation, now is a bear market. So maybe developer becomes a doctor, because for the doctor, they are busy on the work. So they don't really have time to invest or to use their crypto wallet. They just want to put the assets and the general interest. So you just want to have a wallet which can do some DeFi application. So it's really hard for a crypto wallet to fit for all of this kind of user profile. But for the smart contract wallet, it could. So summary. So I think in the future, we will have a modular smart contract wallet, and we can customize any kind of feature to do some differentiation. And then the last thing is scaling, because the smart contract wallet may be good, but for now, it's kind of expensive. Even at the only layer 2, it's still expensive. So once we can fix the scaling solution problem, then we can have a low fee, a smart contract transaction. And yeah, that's it. This is the whole of my talk. Thanks.
Yeah. Any questions? Yep. I think we can move on to the next.